and hopefully you can see that. We look good. Do you see the awesome? Okay, great. Well, happy spring. The black flies have started biting as of yesterday, so I guess we're officially in spring now. Yeah, so it's my pleasure to be with the Harvard Conservation Trust tonight and do a presentation on vernal pools, one of my favorite things to think about and talk about. So as Mark mentioned, you know, if as we're going through the presentation, if you have a question that seems just really burning that needs to be answered, please, you know, give him a chat, and he can break in to my presentation. That's fine. Or we, you know, if it feels like a question that can wait till the end of the talk, feel free to do it that way too. I think, you know, Mark kind of covered who I am. My employment at the Natural Heritage Program was actually a bit ago. I graduated from there around 2002 or thereabouts. And I was the conservation director for a land trust called the Walden Woods Project for 15 years prior to joining BSC Group. But all through that time, starting back in the late 90s and early 2000s, I started teaching people about vernal pools. So we'll talk a bit about that tonight. Just very briefly, if you pardon me, just a little bit about the BSC Group. I'm excited to be part of the company. We're an interdisciplinary consulting firm that works primarily in southern New England. And we do all sorts of environmental science, including regulation work and permitting. We have a kind of full civil engineering, traffic engineering group, and do some really interesting stuff, land surveying and that kind of thing. And one of the things in the ecological services area that we're doing a lot of work with right now is climate resiliency and green infrastructure, which is pretty exciting to be involved in. You know, we're facing some big challenges, and, you know, vernal pools are facing a lot of those challenges too, going forward. And so it's exciting to be part of a group that's thinking about ways to deal with some of the issues that we face. So with that, let me just say before I jump in that most of the images that I'll show you tonight are courtesy of the Vernal Pool Association. As Mark mentioned, we're a 501c3 nonprofit that's set up to encourage people to learn about vernal pools. And one of the ways we really work to do that is to provide high quality images to people that are trying to do education in their community about vernal pools. So that could be environmental signage, web presentation, you know, a teacher having a slide set to work from to present vernal pool ecology in a classroom setting or whatever that may be. If you ever find yourself looking for the perfect image of a spotted salamander, get in touch with the Vernal Pool Association at vernalpool.org, and we're happy to try to help. So what are vernal pools? It's taken me actually a very long time to come up with a fairly simple starting point for this discussion. And I think we can think about vernal pools as small forest ponds that tend to dry up. It's a good starting point. Now, by no means are all vernal pools small. They aren't always in the forest, and they don't always dry up. But it's a good place to begin the conversation to get our heads around what we're talking about. So small forest ponds that tend to dry out. In the Northeast, vernal pools tend to actually be autumnal pools. Most of our vernal pools fill with fall groundwater as it rises, and they will hold water through the winter. A good way to find vernal pools that you might go out and play with in the spring is to go through the forest in the wintertime looking for perfect little skating ponds. It's a good way to identify things that are likely going to be a vernal pool next spring. By early spring, Massachusetts and Northeast, most vernal pools are at their fullest. And they will have the highest amount of water that they will have in the year, and right as the ice is coming off the ponds. Now, this is one of the areas where we are starting to sense some changes in environmental characteristics. You know, the rain sort of comes heavy later in the spring than we're used to, than vernal pools are used to. So we're kind of concerned, watching, waiting to see if hydrologic functioning of vernal pools is affected as climate sort of changes in the direction that it seems to be going. But at any rate, early spring tends to be when vernal pools at their fullest, and they really come to life in the early spring. That's why we call them vernal pools. Vernal, of course, being of the spring. By midsummer, late summer, most, certainly not all, vernal pools will dry out completely. And what this means is that we have this nice little aquatic ecosystem that cannot support fish. And that's really sort of the thing that makes vernal pools really important. They're these aquatic ecosystems that hold water for a couple of months in the spring and summer, into the summer of most years, but they can't support fish populations. And a whole bunch of organisms have adapted their life histories to that set of conditions. And we'll talk a lot about those. One thing to be aware of is that vernal pools are really variable year to year. And I'm going to present you this photograph in a paired photograph that's almost just right. If you notice the tree that's lying over on the edge of this pond here. This is a year that the water starts out in the early spring pretty high. I think this was 2017 maybe, or 2015. This past spring, the same tree is high and dry. It's barely in the water at all. So vernal pools are a very variable system year to year. Not only do they start out holding water and dry out, but they also can hold more or less water given whatever's happening in the environment as far as rainfall and snow melt and so forth year to year. But one thing that is true is that vernal pool depressions tend to be very stable on the landscape. And that's one of the things that is often misunderstood about vernal pools. This variability is not in space, but the variability is really in time. So this is a vernal pool that I visit on a regular basis. It is adjacent to the site at which Henry Thoreau built his house out at Walden Pond in the 1800s. And it's something that I'm certain he went and enjoyed wood frogs and spring peepers and gray tree frogs calling in his spring times out at Walden Pond. And I go out and I enjoy the same thing year to year. This year, the pool is almost dry at the very beginning of the season. We're at a very, very low water this year. But anyway, the pool itself, the basin that functions as a vernal pool, is very consistent through time. So there's a whole bunch of animals that have adapted to this ecosystem. And there are some that have adapted to the extent that they really don't survive successfully. They don't breed successfully in other kinds of wetlands. And these animals that I'll run through right now are what we refer to as vernal pool obligate species. And the kind of bald eagle of vernal pools is the yellow-spotted salamander. Very common across the landscape. And it is the animal, in fact, that sort of initially brought attention to vernal pools in the early 1980s. People started being curious about spotted salamanders. They have a close cousin called the blue-spotted salamander, and that has an even closer cousin called the Jefferson salamander. Those latter two species hybridize, and they have a very strange genetic situation going on across the state. But they are these are both state listed as special concern species. And then finally, among this group of embistomatid salamanders, the close cousins of the spotted salamander, is the marbled salamander. All of these 4 species are referred to as mole salamanders. They are terrestrial as adults. They live underground, primarily in small mammal burrows. They come out to breed in the early spring at vernal pools. And then the other amphibian that is a vernal pool obligate species is the wood frog, a very, very common frog across the state and really across its whole geographic range. And then there are a great number of invertebrate species that are adapted to vernal pools. But the fairy shrimp is a very showy, small, just an inch to 1.5 inches or so in size when it's full grown. But once you know what you're looking for, it's fairly obvious to see, and they are uniquely adapted to vernal pools. They don't breed and they don't exist in anything else. So the spotted salamander, just a great, neat creature to get to know. You might encounter them when you're gardening, turning mulch over, or leaves when you're raking in the fall or early spring. They're fairly large, 6 to 7 inches in length. This kind of chocolatey, bluish, purpley black body with bright yellow spots. Just a neat creature. And like I say, they're quite common across the state, and a vernal pool obligate animal. So they come out to breed when it's very early in the spring. Typically, the first rainy night when it's 40 degrees or better is what prompts them to come out of their burrows and march down to a vernal pool to breed. It can be kind of quite miserable, actually, for us to go out and try to see these things. It's cold, it's raw, it's rainy, but it's a really lovely time to go out and witness some neat stuff in vernal pools. I'm going to pepper this talk with some artwork, so I bear with me on that. I was asked to do a presentation like this for the Mass College of Art a couple of years ago, and I've returned several years in a row now. And what I really love the opportunity to go through the canon of art that's out there and find examples of art that has been directly inspired by vernal pools. And so my first one, if you will, is Escher's rippled surface. If he wasn't standing at the side of a vernal pool when he got this idea in a cold, rainy March, windy day, I don't know what he was doing, but anyway, so I'll include some art as we go. But anyway, these animals come out very early in the spring, and as I said, they are terrestrial as adults. They live in the woods surrounding their breeding sites, and they migrate fair distance, several hundred meters for most salamanders. And unfortunately, that causes them to have to cross roads. And that's one of the places in which we most often encounter these animals in the early spring. Like I say, they live underground, so most people really rarely encounter these things in their lives, although they're quite common in many respects. However, that early spring migration time, when the weather just turns the corner and starts falling as rain instead of snow, that's when we go out looking for these things. It's a good way to encounter them. Quite often they're going down to something that looks like this, which is sort of amazing. You have this small ectothermic amphibian that gets moving when it's so cold, moves a fairly large distance for the size of the creature, and will quite often have to cross patches of snow and arrive at a breeding pond that is mostly ice covered. So it's kind of amazing in that respect. This is a video of what we refer to as a congress. So males will tend to arrive first at the vernal pool and begin this ritualized mating dance, referred to as congressing. They are, as a result of this activity, they're producing little packets of sperm called spermatophores that are deposited on the pool floor. And you can see these little breadcrumbs, white breadcrumbs. And those are quite persistent. You can go out for a week or so after a breeding event and see those during the daytime. So it's good evidence to know that you are near something that had a salamander congress. This happens exclusively at night, only when it's raining. It's a rather challenging thing to encounter, but it's really worthwhile if you can make the opportunity to see it. This is a wood engraving of just this moment from a good friend who is Abigail Rohrer, does wonderful work and is really enamored of vernal pools. She works out of Petersham. And like I say, this is a really neat phenomenon to go out and witness. It brings a lot of people out at unusual times of the early spring, and can be quite a lot of fun in normal times when we don't have to, avoid everyone else all the time. But I highly encourage, once we get back to some sense of normalcy, going out and seeing what is often referred to as big night at a vernal pool, when all these animals come together in a relatively constrained moment in time. Females typically come down a little bit later to the pool. They can be a few days to a week or so after males begin to arrive. A female will pick up sperm from a number of spermatophores, and after a couple of days begin to deposit an egg mass that has been fertilized by that process. They lay their eggs underwater in 6 to 8 inches of water or so, usually attached to vegetation to keep it steady in the water column. After a week or so, the eggs have absorbed a lot of water and become fairly large, much larger than a salamander. That's an often confusing thing for a lot of people, to how did this come out of something that big? But it absorbs a lot of water, gets much larger. Over the course of the spring, it'll turn green with a symbiotic alga, which is kind of a neat relationship. Not always, but often you'll find a lot of egg masses in sort of the sweet spot of a vernal pool. But spotted salamanders tend to lay their eggs individually. So you might, this kind of experience of finding a whole bunch of spotted salamanders in one spot is a little less common than finding them individually placed throughout a vernal pool. The different species of vernal pool breeding amphibians have very distinctive egg masses, and once you get a little bit of practice looking at them, you can distinguish them fairly easily. This photograph shows a spotted salamander egg mass in the center, flanked by 2 egg masses of the blue spot Jefferson complex salamander, we call them, that hybridized version of the blue spot and Jefferson salamander. Wood frog eggs are very different than these. Marbled salamanders are entirely different. I'll mention that later. As I mentioned, they have this symbiotic alga that grows inside the ova. And over the course of the springtime, this gets very green. The alga provides oxygen to the growing embryo. The embryo provides nitrogenous wastes that the alga feeds off of. So it's a nice relationship. When these animals initially hatch out of the egg, they'll graze on that a little bit for a little bit of time for that early boost of energy. Soon after, almost immediately really, after hatching out of the egg mass, a spotted salamander, pond breeding, pond form salamander larva is quite distinctive. Ambystomatids have a big wide head, prominent eyes on the sides, these big brushy gills on the side of the head, and a tail fin that runs the entire length of the body. Right off the bat, they have 4 limbs. So once you're familiar with that body form, if you're dip netting in a vernal pool, let's say, and you come across a salamander larva, you're not going to mistake it for much of anything else that you might encounter. After a couple of months of development, the metamorphosis begins, and salamanders will crawl out and become a terrestrial animal. And it's a couple of years before they have matured and reach a point where they're ready to come back and breed for the first time. Oops, pardon me. So there's an awful lot of really interesting variability that we encounter in vernal pools. Coloration of individuals within a species is one thing that's kind of fascinating. The spot patterns on a spotted salamander actually can be used like a fingerprint. They're that distinctive and permanent in the individual. It's actually been used to document the recurring use of a vernal pool over a course of 15 years at a local pool in Massachusetts for one individual salamander, just by using photographs of salamanders that are seen coming and going. We've documented a 15-year life cycle at least in the wild. Some spotted salamanders will actually have so few spots that they are almost unspotted entirely. This is a leucistic individual. These don't tend to reach maturity because they're such a bright target in a vernal pool. A lot of predators will key in on that. This is not albino. You can see pigmentation in the eye itself and also at the end of the tail. Albinism does occur, but leucistic individuals are a little more common than that.
Hey, Matt, one question that someone had is, do the individual salamanders have an affinity toward their birth pond, or are they sort of willy-nilly wandering around until they find a water source, and if they get lucky enough to end up in a vernal pool, that's where they breed?
Yeah, that's a great question. And in fact, they are quite, the term is philopatric. They're very dedicated to where they came out of. Somewhere in the order of 80 to 90% of a population of salamanders will breed in the pool that they came from. In some respects, they know that it's a functional vernal pool. That 10%, 15% that don't are the ones that go out in the landscape and colonize new pools, try new things out, bring genetic material to new populations. That is a very important function, but the vast majority of individuals will go back to the pool that they grew up in. Good question, though. One thing that's sort of fascinating to me, and a friend of mine, my colleague Leo Kenny, who co-founded Vernal Pool Association with me, documented, is this limb regeneration process. He had a salamander larva in a tank. He was doing photography, photographing its development, and there must have been a predator in the tank. And this guy lost a front limb, his front right limb, on July 7th. By the 13th, you can see a little bit of a limb bud starting back up. Let's use my pointer here to show that. And then by the end of the month, the limb had completely redeveloped, as though nothing had happened. I'm sure the salamander didn't think that nothing had happened, but nonetheless, it's pretty amazing. And there are some, there's a lot of interest in whether or not there are opportunities in human biology to look at what mechanisms are at play here, and see how our medicine might be informed by some of these processes. So I mentioned the marbled salamander. I'll speak on this briefly. Harvard actually is close to populations of marbled salamander. This is a threatened species in Massachusetts. It's fairly uncommon. It's at the northern tip of its range, and so that's one of the main reasons that it's uncommon in the state. Marbled salamanders breed in the fall, August and September. They breed in a dry vernal pool. They lay their clutch of eggs. The female guards the nest until the water comes back, and the eggs hatch, and the larvae overwinter as larvae and grow and feed and so forth through the winter. That's what makes them vulnerable in the Northeast. Our winters don't often work for them, and they have a low success rate. But when it works, by the time the early spring rolls around, they are top dog predators in a vernal pool. So Bolton has well documented populations of marbled salamanders. Harvard, I don't know offhand if there are marbleds documented in town, but it's not out of the question that they'd be around. So it's something to look for. Early springtime is a great time to look for marbled salamander larvae in vernal pools. The wood frog, again, is a very common frog. They are found throughout the region. They are vernal pool obligate species. They only breed successfully in vernal pools. Again, highly variable. They go from a chocolate, almost black color to a rosy red to an almost pale tan color. They can kind of run the gamut. They have a distinctive robber's mask around the eyes and a bright white upper lip that distinguish them from most other frogs. They're small, about 2 inches, 1.5, 2 inches in size. Frogs and toads, of course, are common throughout many cultures. And there's some great artwork all around about frogs and toads. Like I said, frog eggs, all the different species that breed in vernal pools have fairly distinctive egg masses that aren't too difficult to distinguish once you get to know them. Wood frog eggs get to be about softball size, very lumpy. You can notice the lumps of individual ova within the mass. And like I say, once you get familiar with them, they're fairly easy to distinguish. They only last 2 to 3 weeks before they begin to hatch. So they go pretty quickly. Wood frogs tend to lay their eggs communally. So when you find the wood frogs, you're going to find all the wood frogs, usually. They also turn green with this symbiotic alga. And upon hatching, really for a couple of days, the larvae will feed on that alga. And then they become free living and go off and be little frog tadpoles. A lot of fun to see. Right now is a great time to go out and see wood frog egg masses in vernal pools. They are small still. They're less than 1/2 inch or so, kind of uniformly brown with gold flecking on the sides. And if you turn one over in the hand, you can see the gut coil. So that's sort of distinctive. You can begin to distinguish the different species of tadpoles that you might encounter in vernal pools without too much difficulty. After about 6 weeks or so, they're beginning to look very frog-like. Usually late June, They're beginning to metamorphose. This frog has all 4 legs. It's probably breathing air at this point, up near the surface of the water, gulping atmospheric air. And the tail begins to absorb back into the body. And that's the process of metamorphosis. And hopefully they reach metamorphosis before the pool dries out. And that's really the thing that makes vernal pool ecosystems unique. It's what pushes these animals to breed explosively so early in the spring. They are using habitat for an aquatic phase of their life that they essentially know is going to dry out. So it's really a race against drying. Sometimes it doesn't work. Sometimes they don't reach metamorphosis before the pool dries out. This year, we're going to see that a lot. We're already in a declared drought, and across the region, we were starting at very low water levels to begin with. We haven't had a ton of rain yet. We're behind the 8 ball already, or still. And so we'll probably see this a fair bit this year. But that's not the end of the world, because most often, or at least more often than not, a cohort will make it out of the pool, they'll metamorphose, and they'll go out and become frogs, and then feed stuff. And this is really what's so important about vernal pools, is that they are a source of biomass that is a really critical engine in forest ecosystems. Vernal pools are common across the landscape, and they take the energy cycle in a vernal pool begins with leaf litter. There's really typically very little primary production from plants. It starts with the leaves falling into the pond, and that energy processing that happens in these systems turns into hopping little frogs that go out and feed snakes and raccoons and skunks and owls and all sorts of forest creatures, well beyond the limits of the vernal pool. It extends the ecological reach of these vernal pools well out into the forest where these animals actually live. So a couple things about some of the invertebrates that we find in vernal pools. Again, the fairy shrimp is a very unique and distinctive creature. They're beautiful to look at. Again, they're small, very distinctive, the male versus female. The male is on the top. They have a sort of enlarged head with claspers that with the antennae are adapted to clasp females when they're breeding. You can see the brood pouch in the center of the female where the eggs develop. I love this. This is, if you're old enough, you'll know. In the back of the comic books, you could order for $1.50. You can get some sea monkeys, and you'd get a packet of dust in the mail, and you put that into the water, and in a couple of days, you've got little brine shrimp buzzing around your little aquarium. Those were fairy shrimp. So it's kind of fun. There's a whole lot of species in the world. Fairy shrimp occur in France, in Qatar, in Japan, in the desert Southwest. They occur all over the place. In Massachusetts, we have 3 confirmed species, but the most common one is the springtime fairy shrimp called Eubranchopus vernalis. And here's just a ball jar looking down into a ball jar with a little bit of fairy shrimp and Daphnia and other things buzzing around inside my little jar here. I work with someone who didn't believe in fairies, so I had to bring them to work. And a few days later, I saw him taking selfies with himself with the fairy shrimp in the background. So I think we have a convert there. So there's a whole host of organisms that are similarly adapted. They breed only successfully in vernal pools or can use them. we like to refer to them as wee beasties, these little tiny things, Daphnia and copepods and ostracods, clam shrimp. We have 3 species of clam shrimp in Massachusetts. 2 of them are state listed. One of them is known only from a couple of sites in the world, some occurring in Massachusetts. Quite amazing, actually. But these things are mysterious. No one knows very much about these animals at all. But at the right place, these things can just turn into a soup of life. This is a short video I took in a vernal pool in February, late February last year. It was the densest cloud of Daphnia and fairy shrimp and ostracods that I've ever seen. It was stunning.
So Matt, regarding the fairy shrimp,
yes,
someone's asking what their life cycle is, because they obviously don't migrate outside the pool. And then how does the genetic material get, like, how do they not form a distinct species just by being in the same pool all the time? How do they move around? How do they get to a new pool?
Yeah, so these are great questions. The life cycle is fairly simple to answer. The breeding occurs, and the female develops eggs that become encysted. The eggs are drought resistant, freeze resistant, and as she's swimming around the pond, she just deposits the eggs just kind of as she goes. And so they filter down to the leaf litter surface, where once the pond dries, the eggs, we don't really know the mechanisms. We don't know if they need to freeze. We don't know if they need to be dry for a length of time or whatever. There's a lot of mystery there. But when the water comes back, it triggers hatching of those encysted eggs. All the adults die. They'll be dead by early June. The eggs are left behind. If the pool doesn't dry out completely, eggs won't hatch the next year. The pool, the eggs have to get exposed before hatching will trigger. But when the water comes back, magic, they hatch. I find them in December and January and February. Depends when the water comes back, they'll start hatching. So that's all, like, that's magic in itself. How they move around the landscape, who knows? Nobody has an answer. They probably become airborne as dust under the right circumstances, I guess. They probably get transported in mud on the feet of animals that are moving around the landscape. They quite probably get consumed at some level and moved around the landscape that way in the gut of some animal. There's a lot of mysteries about that question, and no one really knows. There's obviously enough genetic exchange between vernal pools over time to prevent inbreeding depression and sort of extinction because of inbreeding. But yeah, I mean, this is who knows? This is great material for doctoral theses and so forth. Good stuff. Great question. So I mentioned that vernal pools are the energy cycle starts with leaf litter. This is what we call a detrital system. And that process begins with invertebrates that take a full-size leaf and cut it up into smaller bits and smaller bits. That increases surface area of the leaf litter, and that gets colonized by fungi and bacteria, and that gets grazed upon and turned into bigger and bigger animals through predation and so forth. There's tons of interesting invertebrates in vernal pools, and I'm looking at the time. I don't have time to go into them all, and I'll probably have to zip through a few of these, but this is a neat one. This is a caddisfly larva. It's a worm-like larva that builds itself a case out of material that it cuts up from leaf litter and sticks and so forth. Stitches it together with a sort of a silk like a spider has. In that case, gives it some camouflage, physical protection, and a safe place to pupate and metamorphose and turn into an adult, which is sort of a moth-like animal. Those are persistent. So you can go to a dry vernal pool and find caddisfly cases and know you had an aquatic ecosystem. And also, if you give a caddisfly pieces of gold and little bits of pearl and precious stones, you can make some really beautiful artwork. This is a French artist who makes jewelry out of using caddisflies. It's kind of neat. Again, lots of really neat biology, lots of creatures that there's just so much to learn about. Little hydra, this is a colonial moss animal, bryozoan, called the ghost moss animal. Really neat. This is under high magnification. This is what that creature looks like in the wild at full scale. I don't know how I recognized it as moss animal, but I said to myself, oh, I know what that is. I've only seen it in 2 vernal pools ever, and they were both in Concord, Mass, oddly enough. Vernal pools are free of fish predators, but they are not free of predators. This is a dragonfly larva, and there's all sorts of invertebrate predators that get into vernal pools and cause some real trouble for vernal pool breeding amphibians, but all part of the web of life, as it were. Water boatmen, coryxids are just really wonderful little creatures that have beautiful patterns when you get to know them intimately under a microscope for weeks and weeks and weeks on end, if you have to do that sort of thing. Leeches, this is a medicinal leech. It's enormous, which actually had its own leeches near its head end. Most amphibians that we have in Massachusetts will use vernal pools. They don't depend on them the way that the others that I spoke of do, but they'll use vernal pools either temporarily as a migratory stopping place, or as a place to feed or even breed if the conditions are right. Green frogs, bullfrogs, leopard frogs, pickerel frogs. Lots of things go to vernal pools to eat. Spotted turtles use vernal pools so much that we think of them as a vernal pool obligate species, actually, in a lot of ways. Vernal pools are so important to spotted turtles. Right now is a great time to find spotted turtles. That they're typically in vernal pools, they're feeding, rehydrating after hibernation, they're mating. This is where they are at this time of the year. Blandings turtles are another one that are real important feature of vernal pools. Vernal pools figure very prominently in the life history strategy of blandings turtles. In places where these occur, vernal pools are a real important component of the landscape for them. Blanding turtles are pretty distinctive. They're large. They get to be 10, 12 inches long. They have a high domed shell, and most prominently this bright yellow chin and throat. When they're basking at the edge of a wetland, vernal pool, what have you, they'll typically hold their chin way up in the air, and so that can really be a beacon to find them, to notice them. You should be aware that there's this Northeast Blandings Turtle Working Group that's focused on thinking about management and protection of populations of Blandings turtles. I brought this in. I think I didn't include the actual website, which was silly. But if you look up Northeast Blandings Turtle Working Group, you'll find these folks. But I wanted to point out the map here, just so you can see the range of the Blandings turtle is primarily focused out in the Midwest and around the Great Lakes. And then there's this one sort of disjunct population in Massachusetts and up into New Hampshire and Maine, very southern Maine, and this tiny little population up in Nova Scotia. So it's a strange distribution, but it's it's something that where they occur, we can look for them in vernal pools and have a good chance of finding them. Snakes, we have a bunch of different species of snakes, but the northern brown water snake is one that is commonly encountered at vernal pools. They're going to be feeding there and sunning and so forth. And like I say, just about anything will go to a vernal pool and feed. This is a fantastic photograph of a barred owl eating a frog. We see this more and more with trail cameras and so forth. We get some really neat evidence of creatures that come to vernal pools for feeding purposes. Okay, again, keeping my eye to the time, we're at 10 of, so I think I'll show you some photographs of different kinds of vernal pools so you get a sense of the scope of what we're looking at, and maybe we'll stop then and see how we look for time. So this first one here is what I think of as kind of the archetype of vernal pools. Small, completely isolated on the landscape. You can just make out a person on the shore of this vernal pool for scale, kind of the size of a small house maybe. They can get much larger, and as they get larger, they'll tend to hold water longer. And when they hold water longer, we'll see different vegetation start to crop up in them. They might be deeper. This one has buttonbush and winterberry and blueberry in its margin. Has some aquatic grasses and other vegetation growing in it. French countryside also has wonderful vernal pools back in the middle 1800s. I don't know what they have now, but we need to go find out. Vernal pools that last longer, hold their water longer, can have much more vegetation growing in them. This is a very green pool. It holds water. It's fairly shallow, almost 2 acres in size, but it holds water almost all year long. Still free of fish, but has a very different character than that completely isolated small pool. Vernal pools can have very interesting patterns of vegetation develop in them that are responding to the sort of regular drying and the different hydro period experienced at different portions of the pool. I was thrilled to discover a painting by Georgia O'Keeffe from her early painting career when she spent a lot of time in New York. And painted a pool in the woods. Obviously, she knew vernal pools too. So before she got tempted away to the desert to paint skulls. Vernal pools quite often will form in the margins of larger wetland systems. So this is sort of the moat around a very large red maple swamp, several acres in size. But just that thin moat, only about 15, 20 feet wide, but about 300 meters long, where vernal pool species had deposited eggs all along the margin of this thing. So they don't always have this classic kind of distinctive pool setting necessarily. Vernal pools quite often occur in river floodplains, meander scars, oxbows, old sloughs that get separated from the main stem of a large river can ultimately function as vernal pools. They may even get flushed with a high spring tide that brings some fish in, and as long as it dries and separates from the water body over time and kills off the population, doesn't allow a population of fish to establish, it can still function as vernal pool habitat. And this kind of habitat can be very important for blue-spotted salamanders, which like lowland, forested swamp kind of settings. Vernal pools occur in the coastal dune strand. in the freshwater lens that can form pools. Won't have spotted salamanders, but some of the toads and invertebrates and so forth, quite common in places like this. And not all vernal pools are natural. This is a man-made feature, part of sort of a backwater that was created in the 1930s by the CCC in Stoneham on the Spot Pond Brook. You know, it occasionally gets a fish or two, but they're not a permanent thing. And the salamanders have found it, and it works just fine for them. So even though it's not a classic vernal pool, it's not completely isolated. It still functions very nicely as a vernal pool. Let's see. So, Mark, what do you think? It's 8 o'clock. So I could stop here. I do have a few more things about kind of management and documentation and so forth, but I'm happy to kind of call it quits at the natural history part of the talk, if that makes sense for your group.
I think that we could. How about if you answer a few questions, and then you can decide if you've got time to proceed on a bit.
Perfect.
All right. So some of these questions in no particular order. Do stone walls form barrier to migration? So we have a lot of stone walls in our woods, or are they an obstacle, or do the salamanders in particular, I guess, who are doing most of the migration, do they manage with them just fine?
They seem to manage with them just fine. You know, stone walls tend to be, for a salamander or frog, tend to be fairly permeable, because they'll find the way through if they need to. Turtles, less so, but they probably, if they're really determined to get somewhere, they'll usually find a way. Some turtles can climb fairly well. Others might find a break in a wall or what have you. So yes and no.
Another question is, you had mentioned the weather conditions that lead to conditions that contribute to like a big night type of event, but it can't just be a function of, a rainy night with temperatures above 40 whatever degrees, because that doesn't happen in November. It doesn't happen in December. So is there some kind of trigger that like number of degree days that a seed needs before it needs to, before it sprouts?
Yes, we assume so, because absolutely right. You get these January thaws, and it doesn't trigger the migration of salamanders. The mechanism is not understood. However, it seems to me to make a lot of sense that it would be some sort of measure of daylight hours or night, dark hours, because that is a very regular thing. And so once you get past a certain number of daylight hours, and you get 40 degrees and rain and you're thawed out, that would sort of say, okay, it's time to go. But that's not experimentally determined. That's just more kind of observational. So the actual mechanism is not known, but it's got to be something like that.
Have you ever seen conditions that are favorable for migration, but then there's like a hard front that comes through and a flash freeze, and it's devastating?
Yeah. So what often happens is that definitely happens a lot. That's just natural. Things look right. You come into the nighttime, it's been raining hard all night, or all day, and into the dark hours, and things start really moving. And then suddenly the temperature shifts, the wind kicks up, and it gets frigid. And that stops migration. It kind of shuts everything right down. But the animals will just find some cover. They'll find a log. They'll get underneath some leaves or whatever, and just wait it out. So it's not catastrophic for the individuals, but it certainly shuts everything down for the night.
Another question was about the hydrology that leads to the forming of pools in the fall, and I was wondering if that triggered the thought, does it have something to do with during the growing season, trees are taking up a lot of water, and there's a lot of transpiration going on. But then in the fall, leaves fall, there's not so much demand for water, or is it just natural cycle of there tends to be more precipitation in the late fall than there is during the summer? Why aren't these pools retaining water during periods of higher moisture in the summer?
Yeah, so most of our vernal pools are groundwater fed, or at least have a significant component of their hydrology is a groundwater component. And so they're responding to the available groundwater. Evapotranspiration, it's a complex mixture of things going on, both in terms of seasonal patterns of rainfall, but then also the evapotranspiration that's happening through the summer really draws down water both at the surface and below ground. So vernal pools dry out, and then as that evapotranspiration begins to tail off, and we'll get a seasonal pulse of precipitation in the fall generally, that groundwater starts to rebound, and that's when they tend to start filling back up. Great. So hydrology is complex, but that's kind of a good, a good collection of facts that play into it.
Good, thank you. And so I've allowed people to unmute themselves. If anyone wants to ask Matt a question themselves in their own voice, welcome you to do that.
What does BCS stand for?
BSC is the Boston Survey Company. I should know that. We don't just call it BSC. Yeah, it was originally founded, I believe, as the Boston Survey Company back in '65. So a little before my time.
Great. And something else that I thought of too is I oftentimes will hear spring peepers, and I was wondering if those they're not an obligate species, I assume. So hearing peepers does not mean that their source is likely to be a vernal pool, but are they often found in vernal pools?
Yes, correct on both counts. They're not an obligate species, but they are one of the 4 species that are referred to as facultative that we can use for documenting vernal pools for the purposes of certification through the state. Mm-hmm. So if you find a good breeding chorus or larvae or metamorphs of spring peepers, you can use that for documenting a vernal pool.
And another question, the state keeps a list of potential vernal pools and so-called certified vernal pools. I wonder if you can explain that a little bit. And I'm curious how many of those potential vernal pools were actually found by scouting on the ground, or if they're using satellite images, or just, how are those determined? And if that's a comprehensive list, should I not bother looking for vernal pools where the state doesn't show a little blue dot where there might be one?
Yeah, so in fact, I created that data back in 1999 through 2001 using 1 to 12,000 scale color infrared aerial photograph pairs. So it was the photo interpretation was done on hard copy aerial photographs. And so that was, there were about 30,000 potential vernal pools identified through that process. I had done a fair bit of field truthing, ground truthing prior to doing this statewide survey that determined that about 85% of the potential vernal pools that are represented in these dots are functional, can be verified functional vernal pools. The remainder, tended to be water features, but weren't supporting the biota at the time of the field survey. Now, this is a good representation of the number and distribution of vernal pools across the state, sort of in a gross term. But when you get down to a particular site, it can quite often underrepresent the actual number of vernal pools significantly. In fact, I don't have a couple of slides that I often present to make this point, but I took a job doing vernal pool certification work back 10 years ago or so on a site that had 11 potential vernal pools identified. And after a whole couple of months worth of field work, we were able to document a total of 50 vernal pools. So there were an awful lot more, non-typical vernal pool breeding habitats that weren't evident in the air photo interpretation project that were out there. And we see that across the board. Like that's not uncommon, that the potential vernal pool is not the end all and be all by any stretch, but it's a good starting point. The certified vernal pool data is, if I find a vernal pool like this one that's in the photograph behind me. I was up in Georgetown State Forest, I think, and happened on this little vernal pool. It was kind of neat. I took a photograph of it. I got down close. I found a whole bunch of egg masses. I photographed those. I can certify that, and that puts one of these asterisks, one of these red asterisks on the map. And that triggers protection under the Wetlands Protection Act and some other things. But the certified vernal pool data are highly essentially biased by the location of people that are interested in documenting vernal pools. And, a lot of people don't want to trespass to do that because that's kind of an issue. So they tend to be biased toward protected open space where you're free to go poke around and find things. So that data is good. They're field verified, they're documented, they've been approved by the state, but they're really focused on areas where people were interested, areas where people were able to go, and or where there was impending development. So the potential vernal pool data are really just using air photography, air photos, what you can see, what we could see from the air that looked like a true vernal pool.
So according to this map that you have in front here, it looks like we're kind of in a sweet spot in Harvard, and it looks like there's another really dense area down in kind of southeastern Mass near the Rhode Island border. For some reason, it seems like there's a real density of potential pools there.
Yes, it's real wet down there. Yep. And then also on the North Shore and in Essex County, the Boxford area is loaded. But yeah, definitely, there's a lot to explore.
And certifying provides a little bit more protection, or does it really not much have much teeth?
Yeah, it actually has some teeth under the Wetlands Protection Act. So certification triggers the Wetlands Protection Act, which doesn't require certification, but it smooths the way. It sort of makes that a little bit easier. A lot of local bylaws rely on vernal pool certification, but then also under Section 401 of the Federal Clean Water Act, vernal pools get protection. The Forest Cutting Practices Act regulations affect certified vernal pools, and also Title V with the subsurface septic tank law, septic disposal law protects vernal pools that are certified too. So there's a lot that certification kind of puts in place.
Great. Yeah. Some number of years ago, the Harvard Conservation Trust purchased a parcel of land that we refer to as the Barba land, named after the former owner. And one of the ideas was to potentially use this land as a housing site, a clustered housing site for an age-restricted development. And upon determination that there was a vernal pool on the site, the trust decided that we wanted to stay clear of intruding on that vernal pool area, and that eventually sort of thwarted the development. The goal of protecting that pond kind of led to that parcel being permanently protected as open space, which is not a bad use. So.
Absolutely, yeah. That's a good story to hear. Vernal pools are they can be pretty heavily impacted by our development work, and so it's good when they are protected for the value of their existence.
Good. And can you mention briefly the Vernal Pool Association? And that I went through some training to learn how to certify vernal pools. And if anyone has any interest, that's a good way to kind of get acquainted. That there's some materials there that you can use to help identify the obligate species in the pool. And it's actually kind of fun. So there are quite a few potential vernal pools that over the past few years, I and someone from Sudbury Valley Trustees has been visiting these pools at the critical times, like right now, to see if they have the species in them that prove that they are indeed vernal pools. And there's a process for certifying, sending the documented information to the state, and it's something that is worth. We got to get more of those dots on the map, right?
Yeah, and it is. It's a great activity. It's a great way to engage your members and get people more intimately engaged in the landscape and what goes on out there. I have just a couple of slides here since we're kind of queued up and talking about it. I'll hit on it real quickly. It is sort of a full contact activity. You have to get into your pool and poke around and find stuff. There are two methods: the obligate species method, which is really the easiest, which requires documenting the pool with standing water and then documenting breeding evidence of those species I referred to, the mole salamanders or wood frog or fairy shrimp. You don't have to have them all, just one or more. And in this time of year is when you want to do that, because egg masses are fairly simple to observe and identify and get a quick photograph of, and off you go. With the facultative species method, it's a little more involved. There are 4 species that count as facultative species, and that you can look up online. You have to show the pool holding water. You also have to show the pool dry, which means multiple visits. You can do the obligate species method in one hit if you want to. Then you also have to demonstrate the breeding evidence of 2 or more of those facultative species. A little more complicated and involved, but still feasible. And then, it requires a bit of effort. You have to go into the pool. You need boots, a net. Polarized sunglasses are real valuable for seeing through the water surface. And then a camera is real important. So that's kind of how you go about playing vernal pool. And you can, the documentation process is fairly simple. Go to vernalpool.org, which is the Vernal Pool Association website, or the Massachusetts Natural Heritage and Endangered Species Program website. And you can get all the sort of what they call the guidelines to the certification of vernal pool habitat, which spells it all out. And then, of course, get in touch with the Vernal Pool Association or me directly if you have questions or, need guidance or anything like that, because we're busy, but happy to help when we're able.
But it's really exciting to get out there and find the obligate species, and you connect with them in a way that really brings some affinity to to the experience. Like, you really feel like you're seeing something which is not common, and it's such a niche environment as a habitat that you really get kind of excited to actually see it in action. So I'd encourage anyone that seems like they're curious, you can get in touch with me through the Conservation Trust, or just go to the Vernal Pool Association and figure out how to do it on your own. But of course, get landowners' permission if you're going on private land. But there are some potential vernal pools identified on the in the state data layer that are on conservation land or on permanently protected land. That would be great to have those certified as well. So
yeah.
So great. If anyone else has any other question, feel free to barge in. Otherwise, we'll thank Matt for presenting this. Thank you for letting me record it. And it was a lot of fun. I really encourage, this is the best time of year for getting out there. If anyone needs to get a hint as to where there might be some vernal pools in the town of Harvard or nearby, just send an email to the Conservation Trust, info@harvardconservationtrust.org, or hctstewardship@gmail.com, and I'll get it. Or you can contact me through Nextdoor Harvard, and I'll let you know where there are some, because they're really fascinating to see. And of course, I should have mentioned that the Harvard Conservation Trust has a couple of events coming up, more youth-oriented, to try to get young people onto the edges of a vernal pool, see if they can, through dipping nets, find some species that identify it as a vernal pool, get the kids excited about it as well.
Excellent.
Thanks so much.
It's a real pleasure to be with you tonight. Thanks for the invitation.
Great. We appreciate you being here and presenting and answering all of our questions. And thank you to all the attendees too. Have a good night.
Okay. Take care.
Bye.